Hey everybody, this is Larry. This is day 21st of June, and today is the Daily Leetcode Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem, and hope you're all doing well and having a good day and all that stuff. Today's problem is Pascal's triangle, which is kind of a nice change for a simpler problem for now, I think. Let me actually read the problem. I also, my disclaimer is I usually solve these live, so it's a little bit slow or not as detailed. Well, leave it in the comments and let me know, or just fast forward or whatever you need to do. Okay, so we turn the first number of rows of the triangle. Okay, I mean, this is very weird, but it also is straightforward. It's probably, I think for me, the first foray into dynamic programming, kind of. I think that's one of the first few things that I've done. But yeah, without further ado, let's get started. A quick question that you might ask yourself, if you're responsible anyway, is that whether this would overflow int. Note that the sum of the ith row of the Pascal's triangle is actually 2 to the I. So given that there are only 30 rows, it should fit within int, which is a 32-bit, of course. Okay, so yeah, I don't think there's anything more to be said here. I don't even know if there's any irresponsible way of doing it. I think this is pretty straightforward. The only thing tricky is just maybe the visualization, but that's fine. I'm a little bit lazy, so I'm just gonna do something like this. Let's go dp is equal to 0 times. So now I make a n times n. I'll chop it off later. I'm a little bit lazy today, because the laziness is mostly in the fact that otherwise we would have to have more if statements, so maybe it's not a big deal. Let's start with the first row, because for the first thing we just do is equal to 1, and then yeah, you go dpx minus 1 y plus dpx minus 1 y minus 1, something like that. It depends how you want to set it up. So yeah, and of course this part has to be if y is greater than 0. So maybe there is some whatever anyway. So of course we didn't really chop it off here. Maybe I should have. Maybe it's fine. But let's just run it anyway, just to make sure that I look okay. Yep, I just need to chop things off, and chopping things off is pretty straightforward. Mostly I was just too lazy about the initialization, so let's actually fix that. I just wanted to, make sure that, you aim for correctness. And I said, a lot. Again, I've been a little bit better about it, but today I have not. So anyway, yeah, let's just do this. dp.append. So now we have this. And then now we want to go from, okay, yu is equal to this. That should be okay. Oh, whoops. Huh. On the X or on the Y? Dum dum dum. Oh yeah, that's what I. Oh wait, whoops. That's why. Is it x+1? Maybe it's x+1. Though, really bad lately. But that's basically the idea conceptually. Maybe I should have just chopped it off, but let me actually go through it because I think I'm rushing a little bit trying to figure out what's going on, but oh, whoops. How did I mess that up? Oh, I know, because this was actually returning -1, but the last element was 0. That's why I was working. That's a little bit awkward, actually. It's still out of bounds. Goes from 0 to x. What is going on, Larry? Oh, whoops. Is this right? No, this should be okay. Am I missing some weird thing, or is it on the first iteration? This is rather embarrassing. It's one of those days. So this is the first. That doesn't seem. No, that seems okay. But the second element is wrong. This should be x plus 1. Yeah, this should be right. Being sloppy. So I think this is the one that I have to also do. Is less than x. There we go, I guess. This is a little bit annoying. That's why I wanted to do it the other way, but I thought that I might as well as keep it clean. Because what I would have done was I did it the other way, which is less error prone, and then just for every element just crop it off. Maybe I should have done it that way, because that was, as you can see, much easier. But okay, that looks okay. So let's give it a submit. And yeah, I don't. So you can't really do faster than this, only because if you want to prove the lower bound, it is output sensitive. There are a couple of fun things you can realize, which is that based off this formula, note that combinatorics, the combination like 5 choose 2 or whatever, is also in this table. So there's some fun things you can do. I definitely recommend just reading up on Pascal's triangle, because there are a lot of random things that just comes up, and it may be a cool thing to learn. But yeah, but this is n squared, where n is the number of rows over 2, if you will. But you know, that's also as fast as you can make it, because that's the size of the output. In terms of space, that is also the space, and also that's as the least space you can use, because that's also the size of the output that you have to generate. So yeah, that's all I have for this one, I think. Yeah, have a good week. Stay good, stay cool. I'll see you later, and to good mental health. Bye bye.